Okay, so now that we're done talking about the CPU, let's talk about memory. So there are two flavors of memory. There is main memory, or RAM, or which stands for random access memory. And there is secondary memory, or disk. So when you buy a computer, you're some of the questions that you're going to ask, it's like how fast is the CPU? How good is the CPU? That's one thing you care about. Another thing you're going to care about, though, is how much memory you have, how much RAM, main memory, and how much disk you have. So the size of those memories are important for different reasons. So I want to talk about these two flavors of memory and then just do some interesting comparisons between the two. So main memory, this is basically what the CPU reads and writes to. So remember, we wrote those programs, a couple of programs, one you did as an exercise and one that we did together, where you were loading stuff from main memory and then putting it in registers and then doing some computations and then loading it back from those registers into main memory. Well, that's what main memory is for. And we know that the CPU is reading and writing data, and it's also reading and writing instructions. Okay. Now, the thing about main memory is that it is very fast. Okay? So what do I mean by very fast? Well, we're talking on the order of when the CPU reads or writes something from or to memory, we're talking about on the order of 10 nanoseconds. How fast is that? Well, you're talking about on the order of 10 to the minus ninth seconds. So that's very, very fast. Now, if you want to compare that to something, a human being, like the fastest, twitchiest video game playing, button pressing human being, can do something on the order of 10, I'm sorry, on the order of maybe 0.1 seconds, tenth of a second, or 100 milliseconds. That's really what I wanted to write here. I was looking at my math over there, so just make sure we get that right. 100 milliseconds, which is 10 to the minus 1 second, or 0.1 second. So we're talking about a difference of almost 1 billion times faster CPU reading, writing to memory, main memory, versus what a human being is capable of doing. So main memory is awesome. So why don't we just use main memory everywhere? And it turns out, like, forget about this. Let's just have main memory. And the reason for that is, well, there's a couple reasons. So I'd like you to think about that for a second. And I'll write some reasons down in just a second, but I want you to think really hard. Like, why doesn't your computer just have main memory? Why does your computer also have a disk? All right, so that's the question. All right, I'm hoping you have an idea, and if not, you can hit pause and think about it for a little bit more, or continue along with me. So there's two reasons. The first reason is cost, which we're going to look at it a second. So it's very expensive to expand the main memory that you have, all right, versus disk. And we'll look at that cost in a second. And the second thing is that main memory is volatile. So when you lose power, you lose whoops, second, no, that's lose. When you lose power, you lose the data that's in main memory. So when your computer battery dies, boom. Well, I guess there's some good computers will save things to this, but let's say your battery totally dies and it's totally dead. When you turn your computer on again, it may have to reboot because all the data got lost. Because when you shut off the power, main memory loses everything. Okay, so that's the problem with main memory. It's expensive and it's volatile. Let's talk about disk now. All right, disk is secondary memory, and um, why would you want disk? Well, you want disk because disk is non-volatile. When you lose power, data remains on disk. So that's good. Um, so there's a lot of different flavors of I shouldn't have said disk here because that's just an example of secondary memory. What did I say up there? Yeah, okay. So I'm going to write secondary memory here. I like that better. Oh, what is going on here? I might have to reboot my laptop or my iPad here because it's getting a little confused here. So secondary memory. So some examples of secondary memory would be like they're still around: DVD, USB stick, a hard drive, a solid state drive. So there's also some of older things you might be lying around in a drawer in your parents' house or something like that. There's something called a floppy disk, and occasionally you'll see a CD. So these are all examples of secondary memory. Now, it's really cool that it's non-volatile, and so you might ask the question, oh, and it's also a lot less expensive than main memory. So then the question is, well, if it's a lot less expensive and when you turn the power off, it remains, why don't we just have everything be secondary memory? And the reason why is that secondary memory is really slow compared to main memory. So we're talking on the order of um, 10 milliseconds or 10 or 1 to the 10 to the minus 3 seconds is about the speed that you're going to see for operations. It could be a little lower than that, which is why I wrote 10 to the minus 3 seconds. So if you compare 10 to the minus 3 versus the 10 to the minus 9th, main memory is 10 to the 6th times faster or 1 million times faster. So main memory is a lot faster, but it's volatile and it's expensive. How expensive is it? Well, I thought it'd be fun to kind of do a comparison between main memory and secondary memory. So let's do that. Let's take a look here. This is my Best Buy search engine here, and I said, oh, I want to get a hard drive. Well, 2 terabytes cost $64.99. All right, so if I go back here, and what I want to figure out is like, how much does it cost per gigabyte for memory? All right, so for a disk, it's $65 for 2 terabytes. So the question is, how much is it per gigabyte? That's what I would like to know. Well, a terabyte, if you don't know what a terabyte is 1,000 gigabytes. So that means that it's $65 for 2,000 gigabytes. And that works out to about 0.03 cents, or 3 cents per gigabyte. All right. It's not 0.03 cents, it's $0.03. That's 3 cents per gigabyte. All right. Now let's look at RAM. Well, RAM 32 gigabytes. Let's see how much that costs. Okay, so here's one. I'm just picking something at random. I mean, there's prices all over the place, but here we've got looks like about $100 for 32 gigabytes. So let's go back to here. So it looks like about $100 for 32 gigabytes. And I had the other one kind of pre-calculated in my head, but I can do this one. So 100 divided by 32 gigabytes equals about $3 per gigabyte. That works out really nice. So that means that the difference between these two is it's about 100 times more costly for main memory. So in theory, you could build a computer that's purely main memory and maybe keep it constantly connected to a power supply. But the cost for the memory side of it is going to be 100 times what you pay if you used a combination of disk and a small, relatively small amount, comparatively speaking, of main memory. So this also illustrates something that happens a lot in computer science and also in computer engineering, which is that this is compromise, right? It's like disks are great, but they're slow. Main memory is great, but it's expensive and it's fast, so that makes it great. So they're both great. So we just use a hybrid approach, a little bit of main memory, a little bit of disk, and we have this sort of hybrid system that has a little bit of both in it. Okay, that takes care of memory.